Okay, so now that we're on the same page about that, let's get started with RSpec. So RSpec is the tool that we recommend. It changed my life when I started using it for writing unit tests and functional tests. And we'll start with this acronym that unit tests should be first. By the way, Dave says I like acronyms, and I do, but I rarely get to invent them, and I certainly did not invent this one. But this should help you remember what some of the desirable properties are of unit tests as opposed to the integration level tests that we've been doing with Cucumber. So fast, independent, repeatable, self-checking, and timely. So let's go through an example and anti-example of what this means. Fast is pretty self-explanatory, but the idea here is that you're going to be running them all the time. In fact, as one of the homeworks suggested, and as we suggest in the book, and I personally do all the time, I keep something like autotest running continuously. So literally anytime I save a file, some set of tests associated with that file are going to be run. And it helps if they're able to run quickly, so I'm not waiting around, and that becomes a distraction to my getting into the groove of coding. Independent is really important. No test depends on any other, so you could do any subset of them, you could run them in any order, and you should expect the same results. And as we'll see, when you're working with an app that stores data persistently, like a SaaS app does, there's a few special considerations you have to think about to make sure that your tests remain independent, and we will see what those are. Repeatable, again, pretty self-explanatory. You run the test n times, and you get the same result. One of the things that you probably know from experience about bugs is that if you can't reproduce a bug reliably, it's much harder to track down and fix. So tests, you have the same attitude, right? A test that is run a lot of times, you should get the same result every time you run it. Self-checking, this is one of the major ways that modern testing, I think, has deviated from the older model of the developers are done and now they hand the product over to the QA people. Self-checking tests means that no human being has to inspect the test output to determine if it passed or failed, right? The test has enough introspection into what should have happened and what did happen that the test knows all on its own if all of the conditions it was checking for got fulfilled or not. So you don't need a human being sort of poking at something and then visually observing whether the right thing happened. And you saw an example of this with the Cucumber scenarios where you can test for things like, did I land on a certain page? Does the page contain some content matching a regular expression? So we'll see that with RSpec, you can actually make much more specific assertions about that kind of thing. And finally, timely, and this speaks to the comment that we just had, that the tests are written at about the same time as the code being tested, because especially when you're talking about unit tests, they do tend to be sort of coupled together. And as the implementation changes, so might the tests. So in TDD, the way we solve that is you write the test before you write the code. The test cannot be out of sync with the code if it got written first. So that's the RSpec mantra, test should be first. And with that, let's dive into a little bit of a description of where RSpec comes from. It's a domain-specific language that is embedded in Ruby. So that means that RSpec is just plain old Ruby code, but it's designed to look kind of like a mini language to accomplish a very narrow set of tasks. And you've actually seen similar examples so far when we did migrations, for example. It's almost like a mini language for describing database changes. If you remember some of the SQL statements that I showed in earlier examples, SQL is a domain-specific language for manipulating relational data. You can think of regular expressions as a DSL. So the individual RSpec tests, each one is called a spec. Sometimes it's called an example. You can run all the specs that are in a single file just by passing the file name to RSpec, and if you're using any terminal software written in the last 20 years that can display colors, you'll get a notation from RSpec where a red line is every failing test, green is passing, and yellow are tests that are pending, meaning you have a placeholder saying, I need this test, but you haven't written the test yet. So the test doesn't actually get executed. A much better way to run RSpec, which you were exposed to in the Hangman homework, and which, as I said, I swear by, is to run some sort of a tool that intelligently monitors which files are changing and automatically runs the subset of tests that it thinks could be affected. Autotest was one of the ones that we set up for use in the homework. There is now a chunk of the Rails community has moved over to using a newer tool called Guard, which is a little bit more generic. And you can look up the documentation on the Guard gem if you want to install that. But they're very similar ideas. The idea is they're both running in the background at all times. And essentially, as soon as you make a file change that breaks something, that breaks some tests, you get an immediate notification of it. So let's take a look at some RSpec by example. There we go. Sorry about the weird animation order here. So suppose we have some code that computes a simple square root. A test for that code might say expect x to equal 3. So one of the nice things about a domain-specific language is you try to make the commands in that language map onto the vocabulary of what you're trying to do, right? And in fact, an expectation is this generic concept in a unit test of something that we expect to be true after a certain piece of code runs. You might also call it an assertion, but for various reasons, I think expectation is actually a little more transparent term. There's also more sophisticated ways. Instead of just checking for equality, I can say expect the square root of 9 to be within 0.5 of 3. Now, this example is a little contrived because the square root of 9 is an integer anyway, but the idea being if you're trying to test computations where things like floating point rounding artifacts might affect the answer, you have more flexibility on what you can say. So in general, you're saying expect something to be true of some object. If you can hold for just 1 second. We can also go further, and we can say if we call a method on some object, and it's a predicate. If you remember in Ruby, there's this convention that when a method ends with a question mark, that means that the method is expected to return a Boolean. So we could say expect x.odd to be true, not to be confused with expect x to be odd. So what does this do? This is a very nice example of Ruby metaprogramming to make life a little more bearable. Basically, this works as long as the object on which you're doing the expectation responds to the odd question mark method, right? So internally, RSpec will use method missing, which you remember from the first couple of lectures, to transform this into essentially the equivalent of the first statement. So again, it's a way of making the code a little bit easier to read, a little bit lower cognitive load for the programmer. If you want to be a little bit softer and you like Stephen Colbert, you can say you expect something to be truthy. The difference between truthy and true is truthy just means it's not false. True means it is exactly the Boolean value true. So this is a small number of, a few examples of a list of matchers. You can say I can expect a certain object to be a kind of some class. So if I've called a method that is supposed to return an object of some class, an instance of some class, I can verify that's the case. And then at the bottom of the page is a pointer to the relish documentation that has a long list of all these matchers in a format that's a little bit easier to read than just the RSpec docs. By the way, relish is a pretty interesting hosted application that is for maintaining user stories. So imagine user stories as a service where you've got all of the stories corresponding to your app and you want a shared, essentially, repository where people can document in more detail what those stories mean. That's what relish is. And a lot of Rails tools, including RSpec, have now found their way into the relish documentation. So if you want to see more, go there. Let me take this brief question and then do an example. Okay. So we can look at this in a little bit more detail. These are a few basic examples. What does an entire file worth of RSpec stuff look like? Well, we can have a describe block, which actually groups together a number of tests. And you can see that describes should be nested. So I'm just giving you an overview of some of the constructs, but we'll go through examples of how each of these is used. Within the describe block, there's a number of examples, and you can see that each example begins with the word it. So this is sort of the defining feature of an RSpec specification or example. It does something. It is expected to do something. It should be defined. It sets the ISBN number. This is documentation that reveals the programmer's intent of what a certain piece of code should do. In fact, the old version of RSpec used the word should for these things, and for a variety of reasons, they've now shifted their syntax to use expect instead. So you can tell that, again, I'll show how to use before in context, but before each example, I'm going to create this book object, and then I've got a number of individual tests that expect various things to be true about the book. And if I ever were to change the implementation of my class so that any of those fails, one of those specifications would fail immediately. If you start looking at what kinds of things you can do in the context of a Rails app, imagine, if you remember when we looked at active record, one of the things we saw is that if you try to save an active record object and it fails for any reason, there's an error that will be raised by active record. So here's a slightly different syntax for expect. You can see that instead of expect and an argument in parentheses, I have expect and there's an argument in braces. So what's going on here? expect can either take just a plain old object, and then you can express what you think should be true about that object, or, as in this case, it can take a block. Remember that a block is just an anonymous lambda. It's a procedure. It's a callable. So why do we have to use a callable in this context? Because suppose that we are testing a behavior that we expect to raise an exception. What would happen if your testing tool runs a behavior that is designed to raise an exception? Well, your test will get an exception, and the test tool will stop because you threw a runtime exception that wasn't caught. But if you pass a block to expect, the block can actually be executed inside of rescuing the exception. So the block can be executed, and RSpec can actually check whether the block tried to raise the exception or not. Right? So this is the kind of thing that I mean about tests being self-checking. Rather than sort of poking at the program and saying it was supposed to have an exception and blew up, and it did blow up, so everything works, you can actually write some code that tries to exercise that in sort of a controlled environment. Other things that you can do, because you can pass a block, is you can do fancy things like this. And by the way, this is all legal Ruby syntax, right? If you just parenthesize from right to left. So suppose, on the other hand, that saving the movie is expected to succeed. If that's going to succeed, then one thing I would expect to happen is that the count of total movies I've saved should increase by 1. So I'm passing 2 blocks. Expect is getting a block, and change is getting a block. And the reason change has to get a block here is, of course, it has to execute movie.count twice, right? If my expectation is expect that running this block of code will change this quantity by 1, the only way you could imagine testing that is to measure the quantity before and then measure it again after you've run the block of code. So in this case, when I use the change matcher, it will actually run this code example once before and once after, and then the expectation is, did it actually change the value of the expression according to what by says? So it seems like this is a lot of syntax. It's really not. Probably there are 10 or 12 of these matcher expressions in RSpec that will take you 80% of the way to where you need to go. But just to summarize the 2 very basic ones that we've seen here, you can pass expect a block. The block will be executed in a controlled environment, and then you can specify an assertion or an expectation on what should be the case. Or if it's not that complicated, if you're just checking a property of an expression or an object, you can just pass the expression or the object directly. Right? So these are the 2 big concepts, is the expectation and the matcher. The expectation is, sorry, let me go back one slide. The expectation here is the expect something, and the matcher is what comes after the expect. It's an expression of what condition it is you're checking, and that page that points at relish contains a huge number of things that just plain old RSpec can check. And in the next section, we'll talk about what are the different kinds of matchers that RSpec gives you if you're primarily testing a Rails app that has extra properties that just plain old Ruby code wouldn't have. Okay, let's pause here to do a check on first, and then see if there are any questions about RSpec. So 2 of the premises of unit testing is that tests can be repeatable and independent. And this question asks, which kinds of code do you know for sure can be tested repeatably and independently? Code that relies on randomness. For example, you're writing code for a casino game where you have to shuffle a deck of cards. And code that relies on time of day. For example, there's a system that runs backups every Sunday at midnight, so the behavior of the code you're testing depends on whether it is or is not Sunday at midnight. So, of these 2, is it the case that we could imagine writing deterministic, repeatable, independent tests for both of them, or only for one or the other, or neither? What's the testing prognosis for these 2 scenarios?